Hey everyone, and welcome to this video. Today we're going to be focusing on multi-digit multiplication. And we're going to do that today with what can be commonly referred to as a box method, which is really just an area model. So those are like terms that you will hear back and forth. Let's also keep in mind here, if we're talking multi-digit, today we're going to be talking about 2 by 2 digit multiplication, meaning you have a 2-digit number multiplied by a 2-digit number. So maybe something like 22 times 34. Okay, so we're going to talk about like how to solve problems like this. We're going to use a box method or the area model, one and the same. And we're also going to talk about how this relates to all the previous skills that we've been building on. So let's dive in, let's play around, let's have a good time. Yay. All right. Well, that was a bad multiplication symbol. I'll use the dot right now. 22 times 34. So that's what we kind of talked about on the opening page. Okay, so let's draw back to what we've known and learned so far. Like, yes, this looks a little different because it's 2-digit by 2-digit, but we have talked about this idea of using a base 10 model in the past. And we're going to do that because really that's what area model is. It's a base 10 model. I guess I should say model. But it's a more effective way of doing it because we're already discovering that, yes, this base 10 model works, but it's also a lot of work. So let's explore that. I want to model that. So if you remember, if we're working like with base 10, right, I'm going to make that little graphic organizer. And then here I have 22. So I'm going to go 10, 20, 1, 2, right? That's what this represents in base 10. Oh my gosh. Sorry, I was trying to highlight those and they just got worse. 10, 20. Okay, so here, this is 22 right there, right? 10, 20, 1, and 2. Okay, cool. And then if we were to model 32 across the top, we'd go 10, 20, 30, 1, 2, 3, 4. Okay, so this is what we've been doing, and this has made sense. And really, though, what gets tricky in this case, as we look at these numbers, because this actually would get very tricky, is this right here is a row of 10. This right here is a column of 10, right? So a 10 times a 10, that would be like 100 here. 10 times 10, 100 here. 10 times 10, 100 here. And then 10 times 1 would be 10, 20, 30, 40, right? So, oh my goodness, right? And I'd have to model this out. And then here, this is a 1 times a 10. So that would be a 10, 20, 30, right? And 1 times 1. And now I'd have to like put all this stuff together. So now I have these hundreds. I have all these different 10s I have to put together. I have to count up all these ones. And as you can tell by my tone and what I'm doing here, it's like, this is messy. Like, we do understand how to build this model and we could solve it this way, but it's going to take time. It's going to be a little messy. So, let's build on this knowledge of what we know to make this a more effective process or a more efficient, right? These are words we like to use in math all the time. It's like, oh yeah, I know how to do this, but here's a way I can do it that's more efficient, right? It takes a little less energy, takes a little less time, and is more accurate. Like, right? I know that I could walk to New York City from Seattle, right? I know I could do that. Is it efficient? No, I know other ways. A plane, a car, a train, way more efficient, right? And so that's what I mean here. Like, we know this base 10 model, but let's use something that maybe could work a little bit easier, okay? So let me show you how we're gonna do that. Same concept. So now I'm gonna kind of outline the same model that we have. but I want to note some sections we've built. So here, right, these 10s, I'm just going to look at these 10s. That's 10, 20, and 30. This makes a 30. And this is a 1, 2, 3, and a 4, right? And if you think about arrays, which is what multiplication is, we've talked about that from the beginning here. If we talk about this idea of an array and columns, what I really am showing here is that if I draw a line here, I have a column, right? This up and down column right here that is 30. So I have a column of 30. And next to it, I have another column of 4. Right, so that's all I'm doing. Like, notice like my model's changing a little bit. I'm making the columns. Okay. Then if we look over on the sides of our rows, this is a 20, right? So I could, boom. And then I have this second row. Wow. Some days, you know, some days you have it, some days you don't. There we go. And this is a row of 2. So now what I'm doing is, instead of drawing out all these base 10 models, I'm actually creating these quadrants or these sections to think about that math. Okay. All right. I'm going to model this in some other ways. So hold on. Don't worry too much. Okay. So now I think about what I'm going to multiply. And the same thing is, when I was modeling, I would say, oh, here's a 10 and here's a 10 over here. And I would model that as 100 and blah, blah, blah. But what we can do here is actually just think, oh, if I look at this whole column, this is a whole column of 30. And I'm going to multiply that whole column of 30 by this whole row of 20. And all of a sudden, look at what we got. We got a base 10 multiplication problem that we've been practicing and doing and saying, oh, wait, I can do that. Like, I know how this works. So again, remember, underline our non-zeros. 3 times 2 is 6. Count my zeros. 1, 2. Use those zeros as placeholders. 1, 2. And 30 times 20 is 600. Cool. Well, that quadrant's done. What else do we have? I notice I have 3 more blanks, so let's solve those. Okay, well, I'm still in a column of 30. So this is still a column of 30, but this time I'm multiplying it by this row over here of 2. That'd be 30 times 2. Now, I'm not going to solve that yet. I'm going to fill out the rest of these quadrants to make sense. So now we come over here, we have a column of 4. And let's multiply that by our row of 20. And then I'm still in my column of 4, and I'm going to multiply that by my row of 2. Okay, now I'm going to go solve these. So same old thing. And this is why we use this method, because look how cool this is. I just created 4 multiplication sentences that I can work with easier than worrying about 22 times 34 as a whole. I'm breaking it into little bits and pieces to help me solve it. So 4 times 2, well, that's 8. Count my 0, that's 1, so that makes 80. 3 times 2, that's 6. Count my 0, so that's 60. 4 times 2, there's no zeros, so that's just 8. So now if I think about each one of these sections that I just multiplied together, right, where normally I could be drawing a model of these, like if we went back to what I had before, I would have had like 600 in this section and so on. And remember I circled earlier, I said, oh, there's these 10s we got to find, and these 1s, right? Well, here they are. I found them. I have 4 of them. What I'm going to do to get my final answer is I have to take these and I have to add them together to get my final product. Right? Remember, product, answer to a multiplication problem. So hold on, I just want to move this over. So we said 22 minus 36. Okay, I mean times 34. Wow, I made all those numbers up. All right, so let's add our circled numbers together. We're going to add all these ones together. So I'm going to have, I don't want to erase things because I want you to see everything, but I am running out of space. I'll try to stick it here. So we have 600 plus 80 plus 60 and then plus another 8. So I'll have to squeeze that in a little bit. But again, now look at this, how easy everything's lined up with just zeros. So 8 plus 6, that's 14. Carry the 1 over to the 100, 748. And there's my answer, 748. Okay. Now, don't sweat it, right? I really went through that and kind of said, look at all this. And you went along, and thank you for playing with me and figuring it out. Let's practice some so it makes a little more sense. Okay, so let's do another one. This time, let's take 29, and I'm going to multiply that by, I don't know, 51. Okay. All right. Now, kind of watch how I can do this now through some steps. Like the first thing I want to do is think about those different sections. So if you remember over here, oh gosh, that's messy. But I made these different sections, right? These rows and these columns of numbers. I'm going to do the same thing here, but to help me do that, I really just going to expand. Oh, expanded form. This is like something we've been doing with numbers since we started doing math. So this is a 20 plus a 9. And if I expand this out, that's 50 plus a 1. Okay. Now, why I did that is because that's going to help me think about these rows and these columns. So this can be my rows. This can be my columns. And remember, the commutative property of multiplication states it doesn't really matter which one I do as rows and columns. I'm going to get to the same answer regardless. But I like to look at it that way. You may look at it the other way. We'll get to the same spot, so don't worry about that. So I'm going to go ahead and think about that model then I could build. Right? It was like this. And if I think about my rows, there was a row of 20 right here, and there's a row of 9 right here. So I'm going to do that. And then my columns, there's a column of 50, right? And a column of 1. That's why I expanded them. And then I can just build out the rest of this. And here are my quadrants now. Here's where I can set up my multiplication to solve. So I'm going to do that. I like to write my multiplication problems at the top first. So this is a column of 50 times a row of 20, right? So if you're still not sure, like pause the video and kind of look at how did I get those numbers there? Where did they come from? Then if I stay in this column of 50, I'm going to come down here. That's another column of 50, right? Same column, but this time I'm multiplying it by my row of 9. Okay, so let's come over and do this column of 1 times 20, the row of 20, and then this column of 1 times this row of 9. So those are the 4 different problems I'm going to multiply. But again, I broke it into 4 problems that are easier to work with, right? Compatible numbers. These are things I can work with in my head easier using base 10 multiplication. So here we go. 5 times 2, that's a 10. 1, 2 zeros, 1, 2 zeros. So really I have 1,000. 1 times 20, great. Identity property of multiplication. Anything times 1 is that number. So those 2 are done. Whew, thank you. 5 times 9. So that's counting by 5s 9 times. That's going to get me 45. 1 0. So actually it's 450. And now I have these 4 numbers I'm going to add together to get my final product. Yes, that you heard that correctly. I'm going to add numbers to get the answer to a multiplication problem. Cool thing about this is, again, look how everything's just lined up, right? Line up your place values. Oh, I wrote a plus sign twice. That was kind of fun. Anyway. Right, line them up. You're just working with zeros. So 9 plus all those zeros is still 9. 5 plus 2 is 7 with another 0. That's still just 7. 4 plus 0 is 4. 1 plus 0 is 1. So there you have it. 29 times 50, or yeah, 29 times 51. That's what that says up there. It's going to get us 1,479. Okay, so this is a brief introduction. I want you to really kind of stop and think about what we did. I pause the video, rewind the video, stop and work, and really think about what you got and what you're doing with it. And good luck. Always ask questions, right? That's one of our norms this year. Continue to ask questions. And as always, thanks for being here, and we'll see you soon.